Hello, this is Dr. Ayeshola Ogundele, Astronautics for Exploit. 28th Century Initiatives of Space Solar Power System. The focus points for my presentation are as follows. 28th Century Space-Based Solar Power Initiatives, Stationary High-Altitude Relay Platform, Space Solar Power System, and Space Solar Power Exploration Research and Development Program. The 28th century, a period between January 1st, 1901 and December 31st, 2000, was marked with various technological ideas, innovations, and events that defined the modern era. Some of the 20th century events are the space exploration, flu pandemic, technological advances, and a host of others. All these events significantly reshaped the world structures and orders. In 28th century, one of the notable proposed technological concepts was the space solar power system. In 1941, Isaac Asimov, in his published science fiction story titled Reason, described a space station transmission of energy collected from the sun to various planets via microwave beams. In 1968, Dr. Peter Glaser of Arthur D proposed the concept of space solar power systems in which a solar photovoltaic satellite will be used for the generation of power needed by humans on the Earth for various residential and industrial purposes. In 1973, Peter Glaser was granted patent for his method of transmitting power over long distances and using microwaves from a large antenna on the satellite to a much larger one on the ground, which is known as a retina. In 1987, a stationary high-altitude relay platform, an experimental aircraft using beam-powered propulsion, was developed with intention of using it as a low-altitude communication satellite for smaller geographical areas. In 1998, the Space Solar Power Concept Definition Study was constituted to identify credible and commercially viable space solar power concept, and in 2000, a technology roadmap that maps out potential paths for achieving the development of space solar power system was developed. Up to this present moment, all the solar power system proposed concepts of transferring power from solar power satellite to the Earth have been through the use of microwave power transmission system, and this is based on its high efficiency and power handling capabilities. For several years, after the initial proposition of the solar power concept, there have been various advanced studies on the concept, its feasibility, and socio-economic ramifications. For example, in 1973, there was energy shortage, and this triggered renewed interest on the concept. And in 1976, a task group was established to look into the past work that was done on the concept and the possible future directions on the development of satellite power stations. The researchers also noted that for a successful implementation of the concept, there should be a cost-effective launch vehicle in place. 20th century timeline is stated below. In 1941, Isaac Asimov published the science fiction short story Reason, in which a space station transmits energy collected from the sun to various planets using microwave beams. And in 1968, Peter Glaser introduces the concept of solar power satellite system with square miles of solar collectors in high geosynchronous orbit for collection and conversion of sun's energy into a microwave beam to transmit usable energy to large receiving antennas on Earth for distribution. In 1973, Peter Glaser was granted a patent, And in between 1978 and 81, there was examination of the solar satellite concept, and various designs and feasibility studies were done. In 1987, stationary high-altitude relay platform was set up. Between 1995 and 1997, NASA conducts a fresh-look study of space solar concepts and technologies. In 1998, Space Solar Power Concept Definition Studies identifies credible, commercially viable SSP concepts. In 1998, Japan Space Agency begins developing a solar power system, a program that continues to the present time. In 1999, NASA's Space Solar Power Exploratory Research and Technology Program begins. And in 2000, there was a large-scale SSP concept being considered, and which is a complex integrated system of systems, and the roadmap was developed. Stationary high-altitude relay platform is one of the initiatives of 28th century space solar power system concept. The stationary high-altitude relay platform system was an experimental aircraft concept which used microwave-powered airplanes cycling at an altitude of 21 kilometers as platforms to distribute telecommunications services within regions of up to about 600 kilometers diameter. SHARP was designed by the Communication Research Center. This picture shows stationary high-altitude relay platform aircraft. SHARP used microwaves to provide energy from a ground station that powered electric motors, spinning propellers to keep the aircraft aloft. The power was also used for the onboard electronics. SHARP could remain aloft indefinitely and was intended to be used as a form of low-altitude communication satellite for smaller geographical areas. The picture here shows SHARP, which was first conceived in 1980. SHARP used an 80 meters diameter array of small parabolic dishes, beaming 500 kilowatt of power to the aircraft at 5.8 gigahertz frequency. The beam was focused down to an area just larger than the aircraft. The aircraft normally flew in a circle about 2 kilometers across, so that the beam only needed to steer a few degrees. The picture here shows SHARP in flight. The SHARP maiden flight took place on 17 September 1987, and the system worked as expected. A line launched by the batteries and captured about 1 kilometer broadcasted shortly after takeoff. The initial 20-minute flight time was extended to over an hour by 5th October. This picture shows SHARP prototype. Space Solar Power System is another initiative of 28th century. The space solar power systems convert energy from solar rays to either microwave or laser energy and transmit it from space to Earth for energy consumers. The system has the potential to solve important challenges facing humanity in areas such as energy, climate change, and environmental conservation. The picture here shows space solar system concept. Many studies have been conducted on space solar power system concepts and technologies. In the 1980s, Japan commenced its SSPS research activities. An industry, government, academia research team introduced a conceptual design of a 10,000 kilowatts class. The picture here shows artist's concept of the laser utilizing communication system. Advantages of space solar power system concept are as follows. Unlike terrestrial renewable energy sources, the space solar power system provides power 24 hours a day under all weather conditions. The solar irradiance in space is 40% stronger than that on the ground. Power can be directed to different locations on demand, and this eliminates the need for power lines. The picture here shows artist's impression of space solar power system. Advantages of space solar power system are the SSPS emits no greenhouse gases and produces no hazardous waste to generate power. The SSPS is less vulnerable to terrestrial natural disasters such as earthquakes. No fossil fuels are purchased to generate power, and unlike fossil fuels, solar energy is not affected by fluctuations in energy prices associated with regional conflict and supply shortages. This picture shows space-based solar power concept that is being considered as a green energy source. So the scientists proposed various space-based solar power concepts over the decades since Dr. Glaser proposed the idea. The SSPS realization. To realize the SSPS, technology must be developed to generate, transmit, and receive power efficiently and safely, to assemble large structures in orbit, to perform in-orbit operations and maintenance over many years, and to launch bulky materials into space. The picture here shows space-based solar-powered system concept. Space Solar Power Exploration Research and Development Program is another initiative of 28th century. Large-scale space solar power system is a complex integrated system of systems that requires numerous significant advances in current technology and capabilities. For several decades, technology roadmaps have been developed. The roadmaps laid out potential paths for achieving all needed advances. The picture here shows Space Solar Power Exploratory Research and Technology Program's Solar Sandwich concept. NASA's Solar Space Solar Power Exploratory R&D Program study results show that space solar power is economically viable if recurring launch costs range from $100 to $200 per kilograms of payload. Investment in reusable rockets technology is the driving force for the price reduction. Demonstration of space-based solar power concept is shown in this picture. The purpose of Space Solar Power Exploratory R&D Program are as follows: to perform design studies of selected flight demonstration concepts, to evaluate studies of the general feasibility, design and requirements, and to create conceptual designs of subsystems that make use of advanced SSP technologies to benefit future space or terrestrial applications. The picture here shows NASA SPS Alpha solar power satellite via arbitrary large phased array concept. The purpose of Space Solar Power Exploratory R&D Program are to construct technology development and demonstration roadmaps for critical space solar power elements, to develop a solar power satellite concept for a future gigawatt space power systems, to provide electrical power by converting the sun's energy and beaming it to the Earth's surface. The picture here shows space solar system concept. For more information, contact Astronautics for Exploit. You've been watching and listening to 20th Century Initiatives of Space Solar Power System, presented by Dr. Anyashola Ogundele, with the focus points 20th Century Space-Based Solar Power Initiatives, Stationary High Altitude Relay Platform, Space Solar Power System, and Space Solar Power Exploratory R&D Program. Thank you.